龚文玉教授，中原大学；吴文清财师大；江海邦海洋大学。So next, I'm gonna ask Dr. Kovich to introduce you and your team. Start from the order.
We are all both from 清新 Academy. 我是许长兴，这是杨尚宇、张佑端、吴正月，好，你好。
Thank you. Next, reporter.
So we are team Tiber. 我是徐爱宇，是白景人，这是吴维忠，这是李勇，这是陈博文。
Thank you. Here comes the reviewer.
Hello everyone, we are Team Insulator from National Jaffa Girls Senior High School. I'm going to introduce our team name, 朋友节，所以让杜伟珍、杨凯文。
Alright, thank you. 时间。我们已经差不多可以了。不是差不多可以。所以你可以的时候，我们就开始。
所以你们这里有
那个 timer。
你们有人有带笔电吗？
没有笔电。这应该是最后考 PPT。
对，这个东西就等一下哦，我去找找看。
接完了，都是有个简报是不是？是在你那边还是在我这？你要自己讲。
所以现在可以。哦，没有笔电了。啊？哦，是我是有打不开。有电吗？还是？再调一下。你都用手机的。什么意思？哦，这可能是电出一点小问题。哦，你买的？哦，对，已经在这里。你是你。
你就要在路上，你就在路上。
9206密码。这个网址我传给你，你要滑鼠吗？我滑鼠。
长教授。再问一下你的那个方面。
你有去这边？
去年毕业的一个博士生是4张一考试上，那大学部也是工作室。最主要最想做它。或许是那个时机，因为炒得很凶，刚才说了，所以你要看一个，
这个是
一整放做合聚合融合，
他们每个人融合，
美国也有几家startup都是在做这样。可以了吧？
对呀，我要看那个。
哦，那个 timer。
那我拿，我给你一张纸。
又不是直接插头。
那我刚查，它是这一台我刚拿没有看，对，
哦，
给我那个那张纸，我要这个那个机。
就这里接过来，真正接过来这个会留一个是给你接电脑，然后这3个是到前面的。
为什么是那个是？
是我给了。啊，你用这样的方式，哎 ，smart。Oops， 没打错。
半形全筋料理。
那个大小，那个要大小。
对，你这还可以。
没有，你key 进去是。
我是小写，是这样子大小。哦，
应该没错。
All right. Yep. 对对，然后 What's next？
介绍完。
然后对，介绍完了，然后就是 timer。Oh yeah. All right. There you go. So let's start. So here comes the first stage. Timer 我看到。
摄影机可以吗？
开始。我挺按暂停。
你就先停一下，我讲完你再开始。
哦。
不然我讲的时间都扣掉了。
对啊。
All right. So here comes the first stage. Important. You have 1 minute to challenge reporter for one problem. You may start. 开始。
Start.
开始。就开始。那个 screen 可以变大吗？可以放大。
这个不是我们投影，我自己点。
clock 应该弄。
对啊，
应该弄。
在中间，但是。
那我们先停下，先那个 timer 先停下来。对 ，clock 应该在中间对。
写到什么？刚写过，不让我写。就只有那2条线。
还是一样，它是这个在中间哦，投影机。
找中间的讯号。
对啊，你就反看其他条连到
中间的按。
它那个我觉得应该是 on 的。
这条是谁写的？然后当初场地到底是？
这个 output 的数据，反正30。
它投到中间的。
那个要不是剪切上去的，没有，这个电动擦掉，有一条是电动不可能的。
对啊。
有一条直接接为什么没有？
对啊。
Alright, there you go. Alright, so let's restart over again.
这个是备用的。
So we want to oppose the track meters, problem 13.
Problem 13 was challenged. Reporter, you got 1 minute to make a decision. Problem 13. Oh, you can time. Next 1 minute. Charge meter.
3吗？
properly accepted. So reporter, you got 5 minutes to prepare for the presentation. And please write down the representative on the platform, please. The name on the platform. You may start if you like.
Good afternoon, honorable jurors and fellow competitors. I am the reporter from Team Overworld, and I'm going to report problem number 13, charge meter. So this is the problem statement. A lightweight ball is suspended from a thread in the area between two charged plates. And if the ball is also charged, it will be deflected to one side at a certain angle. So I will have to calculate the accuracy of such a device and optimize the device to measure the smallest possible charge. So the main focus will be the angle and the accuracy and uncertainty of my measurement, and also the smallest possible charge on the bulb. So for the observation, I will show the phenomenon and also analyze the movement, and for the theory part, I will talk about these and make a theoretical calculation. So this is the observation video. We can see that when the electrostatic force is given by the plates, the charge sphere will deflect to a certain angle. And we use the Wimshur's machine to generate the electricity, because also when the rotating velocity increases, the voltage it generates will increase. And we choose this machine because it can generate a larger and also adjustable voltage. And so in this video, we can see that as the rotational velocity increases, there will be a threshold that the sphere will hit the plate, which the deflected angle when it touches the plate is 40 degrees. So we don't want it to touch the plate. So the deflected angle will be smaller than 40 degrees in my experiment. So these are the phases of movement, and we can see that as the rotational velocity increases, the deflected angle also increases. So this is how a Wimshur machine works. So when we rotate the machine, the electricity will go to the plates, and it will generate an electrostatic force which makes the sphere deflected to a certain angle. And the theta is what we want to measure. So in my observation, we can note that the rotating velocity is positively related to the charges, and this is the machine which the metal brush on it is used as a charge transmitting and neutralization, and the Leyden jar stores the positive and negative charges. So this is how it works. So simply the two plates will rotate in the opposite side, which one of them will store the positive charges and one of them will store the negative charges, and when it meets the one side of the Leyden jar, the charges will be stored inside and be generated by the small ball. So for this part, we know that the electric charges will, on a neutral object, will redistribute, and the charges in the sphere will generate the same electrostatic force on both sides. So in this problem, the charge sphere will have an uneven amount of negative and positive charges, which the force will be different, so it will be deflected to a certain angle. So this is contact electrification, which when we use a specific charge plate to contact the sphere, and the plate will attract the opposite charge outside of the sphere, and so the charge will redistribute uniformly when the plate meets. So this is our way to charge ball in this experiment, and we control the contact time for 5 seconds. So this is the force analysis, which we can know that the electrostatic force that I later on use will be Fg tangent. And my sphere is 4.2 grams. So this is the theoretical calculation, which when we calculate it, I want to know like the smallest possible value. So we know that the breakdown voltage of air is approximately like this. So we can calculate that in my experiment, the parallel plates, the distance between the parallel plates is 18 centimeters, which the electric field will be like this when the breakdown voltage appears. So, and I mentioned that the degree will be smaller than 40 degrees. So the largest, so the smallest number of the charge should be like this, and the practical number of the charges that I measured should be bigger than the theory because when the experiment is done, there is no breakdown voltage, so the E should be smaller. And so we know that the force and the voltage is what we can measure, so we can use this formula and also the accuracy defined method to find the value and also the uncertainty of the experiment. And so these are the values to measure. First of all, is the deflected angle, and also the weight of sphere that I mentioned before is 4.2 grams, and also the distance between the plates is 18 centimeters. also that because in my experiment I need to optimize my device to get the smallest possible charge. So I want to control, like there are no estimated value at all. So I try to control every value like it is specific and without a type A uncertainty. So this is how I measure the rotational speed, which I count the numbers of turns and divided it by the length of the video that I record. And this is how I measure the distance. So the digits of the type A uncertainty will be 0. So in this picture, we can see that the calculated value that I need, the uncertainty will be like this because the least count divided by 2 times the square root of 3 is the type B uncertainty only. And in this part, we can see that I calculate the electric field that I need by the voltage that I measured and also the distance between the plates. So the uncertainty calculation will be like this formula. And so the smallest possible charge is what I want, and the F I can get it with the ng tangent theta and divided it by this electric field. And I need to calculate the digits under the decimal to find the smallest possible charge. So this is my experiment setup, and that is the software that I use to measure the deflected angle. So it simply looks like this, and it will show you the degree that you pointed out on the screen. And so to control the rotational velocity, we use a drill that can control, like the RPS of the drill is fixed in the same force that we give it to it. So it will work like this, so we can control the rotational velocity of the machine. And these are my variables, and the dependent variables that I need to measure is the degree of the deflected angle, the measurement uncertainty, and also the amount of charge that I have to calculate. So these are the videos that I've recorded, and their corresponding rotational velocity. And we can see that as the rotational velocity increases, the degree increases. And these are the deflected angle measured under the same amount of charge on the sphere, which is the same time of experiment. And also, I've done it for 3 times and get a type A uncertainty and also a component uncertainty. And this is which I transform the degree that I measured into the electrostatic force. So these are the force analysis and also the average and uncertainty to the corresponding rotational velocity. So for this is the graph that shows the electric force that calculated under different rotational velocity. And we can see that it is exponentially correlated to the rotating velocity. And in this part, I measured the voltage and divided it by the 18 centimeters to get the electric field, and I use this equation to calculate the measurement uncertainty. And we can see that the voltage measured under the different rotational velocity is also exponentially correlated. So this is how I measure the charge. This is how I calculated the charge on the sphere. So you can see that I divided the electrostatic force to the electric field, and also I calculated the uncertainty here by the formula that I've mentioned before. So in this picture, we can see that the uncertainty is about 10 to the power of -9. So the smallest possible charge should be a digit bigger than the uncertainty to be accurate, that there is no uncertainty in that digit. So the smallest possible charge will be 8 digits under the decimal that I can be able to calculate accurately. And so in conclusion, the rotational velocity of the Rimscher's machine will be exponentially correlated to the electrostatic force and also exponentially correlated to the voltage of the plates. And the smallest possible charge from this device is limited to be bigger than the digits of the uncertainty, which is 10 to the power of -8. And in the discussion part, I want to discuss my way of charging the sphere. Because as I have mentioned, I use the contact electrification. But however, for the same time of contacting, the amount of charge should be the same. However, there is a uncertainty between them. So I think my way in this experiment to charge the sphere is not very accurate. So to become more accurate, the time of the contact electrification should be more specific, or I should come up with a more detailed way to charge the sphere. So this is the end. Thank you.
All right, thank you. Questions from opponent to reporter for 2 minutes.
So first, I want to ask you about the mass of the ball and the thread. Do you consider it will affect this phenomenon? The mass of the ball and the thread.
4.2 grams.
Do you consider it will affect?
Yes.
Okay. So how about the material of the ball and the thread? Yes or no? Do you consider that it will affect? Because like I consider the thread will also be charged. So do you consider that it will affect?
The thread
Sure.
is not conductive.
Okay. So how do you measure the angle? You just use I didn't know how you measure the angle. So
I measured it by the software.
I got it. So if the ball is always discharging after the experiment, so I consider that there will be still charge on the ball.
I will touch the ball every time.
I got it. So does the insulated ball also cause the charge distribution? So because you say that you the charge will redistribute. So do you consider that maybe the material would affect this phenomenon? Just how it affect the redistribution?
No.
Okay. So what's the minimum unit of your device? I consider you use the uncertainty, right? So what's your B-type uncertainty? You would need to know the minimum units of your device.
Like here and here.
So it's a
The
both.
least count. Which one do you want?
Oh, okay, I got it. So then did you change the material of the plate?
No.
I got it. So in your setup, I consider your setup would just your drill would accelerate, or you just control that in a state.
Yeah, it's static motion.
Okay. So does your accuracy include the uncertainty, or the error, or the precision? So the person will say that is the accuracy, right?
Yes.
Excuse me, time's up. Opponent, you got 3 minutes to make a declaration. All right, opponent, you may take the stage for up to 4 minutes, followed by a discussion with reporter for 14 minutes total.
So I'm an opponent today from Team Hybrid. So this is a power statement. So a lightweight ball is suspended from a thread in the area between the two charge plates. So if the ball is overcharged, it will be deflected to one side at a certain angle. So the reporter has to know the accuracy of such a device for measuring the amount of charge on the ball. So they have to optimize their device to measure the smallest possible charge. So this is my main focus. I can say that they have to do the measuring the amount of charge and measure the charge on the ball. So this summary of report. So for theory, so I can say the reporter has the quantitative understanding, and they use the motion and the force analysis, which is the force equilibrium, to analyze the common force. And they use the electrostatic induction, and they have and they control the contact electrification, and they consider the breakdown voltage, and the accuracy and the uncertainty. But I will discuss later, just because I consider that the accuracy will have different definition. So I will ask the reporter later. So they also try to change, control the rotation velocity. And for experiment, they use a windshield machine to get the charge, and they measure the deflecting angle and control the RPS, and they count the number of turns to control the electric field, and they try to measure the voltage and the smallest possible charge, and they do some graph to show their how RPS affect the voltage and the deflecting angle. And that's for strength. So they have complete quantitative phenomenon explanation and have a simple physics explanation, and they also have to do some experiment to prove their analysis is right. But I will discuss later, just because I consider that the report say that there will be many errors in their device, but I consider the graphs have very match their theory. So I will discuss later. And for a suggestion, I consider the reporter have lack of some explanation for experimental result, because they just show the graph, but didn't explain why it will cause the best accuracy. And for the model, just because, just like I said before, just because the report say that it will have many error, but it very matched with their experimental data. And I consider the report has to define the accuracy more clearly, just because I consider the accuracy will have the error and the uncertainty and the precision. But I consider the report didn't really clarify it. And yes, and for a discussion, just I asked before, I consider it would the weight and the material of ball would affect. Just I consider the ball weight is too light, it would affect. And yes, and the material of thread and the curve the thread will affect. And for a method, so the way they calculate voltage and measurement of the charge on the ball, just because they just control the RPS, but I don't know how they change the voltage from the RPS. And for data analysis, so the definition of accuracy, precision, and uncertainty, and the relationship between the RPS and the voltage. And for data, so the error of the experimental results, angle deflection, and the charge. So thanks.
All right, move on to discussion.
So first, I want to ask you the definition of good central problem statement 8 page. So the problem statement say that it's accuracy. So how to define the accuracy?
I define accuracy as like I can confirm to like this digit as a.
So you consider the accuracy is the uncertainty or the error you have made?
No, not the uncertainty. The one without uncertainty. The digits without the uncertainty will be accurate, and if the uncertainty is added, the digit will be inconsistent.
But in your later graph, you show that you just use uncertainty to calculate the error, right? Just because the mu of x, just like the graph, good central graph part. Yes. Yes. So I consider that the square, the b over d, is the uncertainty.
Yes.
Yes. So, but you just say that you didn't use the uncertainty to define the accuracy. So could you explain more about it?
Because I mentioned that I think that the accuracy will be
in your setup, just because you always use a drill to control the angular velocity, right?
Yes.
So, but I didn't know how you change the angular velocity from the windshield machine to know the voltage of the windshield machine to keep.
Okay, so this drill has different stages. Like the setting of this drill has different stages.
Yes.
But I control it in the same stage to make sure the rotation velocity is the same.
Yes.
And I measure the voltage by the machine.
So how do you measure the voltage from the machine?
I measure I measure it on the plates. I measure the voltage on the plates.
So you use another thing to measure the, yes. So
Like the machine to measure the voltage.
Just because like you always control the RPS. So at the end, don't let you consider like there will be error and some uncertainty of this machine. Just because you just use another machine to measure the voltage of the windshield machine.
I think that because I focus on the voltage that I've measured.
Yes.
So there is a graph that I draw that the voltage will be exponentially correlated because these are the voltage that I measured and these are the corresponding rotational velocity. So like in this environment, these values are measured like this.
Okay. So and as this graph, your model really match with your experimental data, but you just say like it will be a mere error in your device. So how do you get this data? Could you explain more about it?
What error?
Just like the page 28, just because the theory very match with your experimental data, but in your device you say like there will still be some error and uncertainty in your device. So could you explain more about why it very match with the figure?
In these graphs, because the numbers here are too big, so the error bar is very small, but actually there is something like there is error bar, but it's very
Could you show me an error bar graph?
very small. There is error bar.
I got it. So there is error bar, but I can tell it's very small, right?
Yeah, and the values are like.
Okay. So I can say reporters still have to optimize their device, but I would ask more about the setup. Just so how do you control the contact time? You just say like you control the contact time, right? So how do you control it?
I put the sphere onto one of the plates.
Yes.
And then I use a timer to set like 5 seconds. And that is why in my discussion I think that I should be more accurate in my charging.
Yes. So as you say, so this is what caused the error, but you say that the error is very small. So so this is how you optimize this device. So because the problem statement, you have to optimize this your device, right, to measure the amount of charge.
Yes. So what I used to make me able to measure the smallest possible charge is that I use different methods to keep the estimated value to be 0, so the uncertainty will become small, like only the type B uncertainty. So these and the method that I use and also the software that make the uncertainty, the type uncertainty 0 is how I optimize my device.
So you consider that is your the best device to measure the amount of charge.
And also that
Okay, so I want to ask like how the charge from the machine and pass through to the ball. So the amount of charge will be the same as the electric field give it, or how do you measure and calculate the amount of charge on the ball?
I calculate the electric force that is given to the sphere,
Yes.
like I mentioned, and also I use the voltage on the plates.
Yes.
So not the machine and the ball on the machine. So if the ball is touching the sphere, so the ball on the machine distributes the voltage to the plate.
Yes.
And I'm afraid that there will be a little difference on the ball and the plate. So what I measured is the voltage I measured is of the plate, not of the ball.
Yeah. So as you say, like you only measure the charge of the plate. So I can say it would be error to just as the voltage to the ball. So I can say the error value should be not so small. Could you explain more about it? just because you just measure the voltage of the plate, not the charge of the bulb.
Yes, so the voltage is determined, like there are no uncertainty of the voltage because the machine shows the number. And I divided it by the distance between the parallel plates
Okay.
to calculate the electric field that is given to the sphere.
Okay.
So I think that is.
And for a proper statement, it says that it has to be a lightweight bulb. So what's your weight of your bulb? Could you
What was
tell?
4.2 grams.
Okay, so do you consider the light it will cause a different deflecting angle? So I consider the mass of the bulb will also affect. So do you try to use a different mass of the bulb? Yes, so because the person say the lightweight bulb. Yes.
Yeah. So this bulb is the lightest weight of bulb that I can find, and also
Yes.
I think that the lighter the bulb is, the more accurate I can be because there's more digits.
So you consider the lightweight bulb can get the best device, got the accurate amount of charge.
Because there will be like this will be smaller. So this will be smaller.
Could you
Okay.
please?
Because if it is lighter, like I can measure to more deeper, then this will be smaller, right? So just these kinds.
Yes.
So this will be smaller, and I want this to be smaller, so I want this to be smaller.
Okay. So I consider you use the Windsor machine to control electric field, right?
Yes.
So how do you estimate and know the force, the Coulomb force? The force, the plate, the electric field give to the bulb. Could you explain more about the force part?
I analyze the force in this mode.
Yes.
So this is when it is deflected to a certain angle and it's fixed. So yeah, just conclude.
So you just use the G tangent theta to know the Coulomb force. Okay. So could you explain more about the compare the theory part and your experimental data? Just yes. So how your measurement of the real charge compares to the theory?
Okay, so because this is the biggest, the breakdown voltage that is one. So this is the my practical number should be bigger than the theory. So this is what I want to say, that if I measure it and the answer is smaller to this, then I can know that maybe there are some mistakes in my experiment.
Okay, so for this page, could you explain more about the breakdown voltage? I didn't understand.
Oh, the breakdown voltage is like when the voltage is big enough for the air to become. There will be you can see a flash between the two bulbs. That means that the air can distribute the voltage will become big enough to distribute the charges.
Yes.
And that is the breakdown voltage. Like you can see the lightning.
So you, when you see a lightning, I didn't consider it accurate just because the eyes are not so accurate.
This is a fact. Like this research.
So you just got the theory part. So you didn't know the accurate breakdown voltage, right? I mean, in your experiment, it is a theory one. I mean, so did you know the breakdown voltage of your device? I consider it will also cause the air to your figure.
It said off like in the air.
Excuse me, hands up. Opponent, you may summarize the discussion in 1 minute.
So I mainly asked the reporter about the setup. So the reporter used a drill to control the angular velocity. But I didn't consider that the reporter has done a great job on change the RPS to the voltage, just because she just used another device to measure the charge of the plate, and not just directly from know the voltage and equation to get the charge on the Windsor machine. And I also asked if the reporter had changed the mass and the material of the bulb, just because I consider the material of the bulb will also affect how it is charged. Yeah. So the reporter just used the minimum mass of the bulb to control, just because the reporter consider it can lead to the more accurate. So I also asked about how did the reporter optimize the device. So the reporter just say that she can control RPS and the plate, so it can.
Time's up. Questions from reviewer to reporter and the forum for 3 minutes.
Okay, I'm here as a reviewer, and I have some questions for the student and reporter. And the first question I want to ask: do you think the hollow or the stroke of the board will affect the experiment results? The hollow or the solid? Solid. The hollow or solid will affect the ball.
My experiment is
Will affect? Yes or no?
yes.
To explain more about the horror one.
In the ball, it will hollow will affect.
Oh yes, I can say it will affect.
Okay, and the next question I want to ask: if the charge of the ball is the same, but you change it in a positive and a negative positive charge, and it will affect the experiment results. Okay. Next question. What is the limit? I think size and the weight of the ball will change the experiment. And have you investigated the limit of the size and the weight of the balls to make a magnetic field?
I don't think the mass of the ball will change a lot. It may only change the accuracy, but the value should be because the amount.
So you think the weight of the ball is can ignore in this experiment?
To be more accurate, it should be smaller, but I don't think the charge that I put in will be different.
Tall and the size of the ball. What do you think it will affect?
I don't think it.
Okay, and I want to ask do you think the size of the ball will affect this?
I can say it's the mass of the ball will affect because the report is for equilibrium to calculate the column force. So the different mass of the ball would contribute to the different column force they calculate.
Okay, and the next question I want to ask that because I think the size of the plate will affect the experiment. So I want to ask that how big do you think it should be have a more uniform electric field with the plate in the experiment?
So I said it's parallel, so I think it is beautiful.
Because of I think the size of the plate will affect. And do you think the size of the plate will affect? Yes or no?
Yes.
Yes. And
I can say the size of the plate didn't affect just because they just want to know the voltage on the plate. So the size of the plate is not the main reason.
okay, and I want to ask both do you think it will make a magnetic field during the ball motion? It will make a magnetic field.
Excuse me, time's up. Review, you got 2 minutes to prepare for your review. All right, you may take the floor for your review.
Okay. And hello everyone, my name is Yuan from Team Insulator, and today I'm going to review the problem transmitter. And in this
我不能控他们啊。
and I'm going to review the transmitter.
One second, please.
And this is a problem statement and
Just a
this
second.
is-
All right. Restart it.
And I'm going to focus on the limit of the perimeter and how does the perimeter affect the experiment result and the measure to calculate the electric charge of the board. And this is overview of the report. And in here presentation, it has a empirical model about the content of electric channel, and in here experiment and setup, it has a relationship between the calculate and the diffraction of the angle and data analysis of the rotating velocity of the different parameter and voltage of the plate and the smallest possible charge and change on here. And in her empirical models, and we think here Pons is enough to explain the phenomenon, and in their Pons, we think it didn't explain the theory clearly and didn't connect with the experiment. And in her experiment and setup, we think here Pons is nice on the direct and clear explanation. And in her task, I think is lack of important parameter in the investigate, and in her data analysis, we think his pros is a well investigate of the result of the different parameter, and in her pros, we think it compare the theory and experiment, and didn't have the accurate way to calculate it. And this is the overview of the report, of the output. And in her short question and speech, it discussion about the measure of the angle and material and the mass of the bolt and the material of the plate. And in discussion, they discussed about the experiment setup and the uncertainty of the experiment and data analysis, rotation and the reason of the reflection angle. And in the opponent, I think his plot is clearly describe the error in the reporter's presentation and explain his own opinion about the experiment process and results. And I think his count is to focus on the perimeter and didn't mention theory in here. And in discussion times, I think his pros is point out the error in the experiment process, and next suggest about the perimeter which will affect the experiment results. And we think his count is to focus on the perimeter report didn't do in her experiment like a mass in her bolt, and to focus on the detail of the experiment setup and to focus on the measures. And in the discussion time, in the discussion about the setup and some error bar in here, and in our question, I asked that both of them, do you think that whether the bolt is a hollow or solid will affect the experiment results? And the reporter said, yes, she think it well, and opponent said, yes, and he think it well. And I also think it will affect this experiment results. And I also asked that, how big do you think it should be have a more uniform electric field? And the reporter said, the size is not important, and opponent said, he think it's a main effect to affect is not the size, and his thing is mass of the bulb is more important. And in her meeting point, I think they didn't discussion about how well the plate distance affect the results, and it didn't mention about the size of the bulb and the place. And I think it's important in this experiment, and just like the weight and the size in the bulb, it will affect the magnetic, the electric field in it, and it will affect the ball to move the theta in here. And this is our presentation, and thank you for your attention.
All right, thank you. Here comes the last stage for the reporter to make conclusion remark for 2 minutes.
Okay, so first of all, I think that the accuracy means that the resist without the uncertainty, and how to produce the different angular velocity is Ali's real. And the error bar is very small in my experiment, and the time range should be more accurate, like how I charge the ball. And the larger ball can be more accurate because the least count of the grams. And I think the size of the plate will not affect it. The mass of the ball may somehow change the result, but in my experiment I used the same ball, so I didn't change it. And for the reviewer part, they mentioned that I didn't connect the theory and the experiment. However, like I introduced the electrostatic induction because I want to know that when the sphere is charged, there will be an uneven amount, so there will be a bigger force in the other side. And also that I mentioned the contact electrification because that's our uncharged ball. And also I mentioned the motion in the force analysis that I use later on to calculate the electrostatic force. And I mentioned the measurement and the theoretically calculation because I need to know that the practical number of the charges should be bigger than the theory. Thank you.
You done?
Yes.
Right. How's the question for Jerry? Remember? Yes.
I'd like to clarify from the reporter that how do you determine the uncertainty of the charge? I mean, you said like in various cases you have 0.0029 or even more, almost zero yet. But so it's much bigger than what's the minimum number, smallest number of the charge you can measure. I think that's your conclusion. So you said, I mean. So how do you determine the uncertainty of the charge?
Oh, because I didn't have a estimated value, so I used the least count and I calculated the type B uncertainty, like the least count divided by 2.
All right. Any more questions? Yes.
Can you explain what you mean by type A, type B, uncertainty? What is that?
I learned it in class. It said that when you measure a lot of time, there will be a type A is like when you measure, there will be different results when different time you measure the same thing.
Statistical
There
error.
will be a type A.
So you keep the measurement many times, and you get the average, and then look at the deviation. Is that the thing by type A, right?
No, I make type A uncertainty. I want to control it to 0 because I want smaller uncertainty. So,
Experimentally, you did that?
yeah, so I measured them and I didn't have an estimated value, so there will be no type A uncertainty. Right?
Yes.
The reporter, please attend to the conclusion of the next page. Yes, can you explain why the rotation velocity is correlated to the electric force is exponential? Can any explanation about the results?
Actually, I only know like how does the Richard machine generate the voltage, but I don't know like how does the rotation velocity is related to it. So I make different values and I draw a graph to fit. And the most fitted line is exponentially correlated.
Yeah, I just want to know the physical insight of why.
I didn't investigate it.
And so, the opponent.
Yeah, any comments from?
Yeah. Do you have any idea about the results?
So from my perspective, I can say that there has to be equations that can just directly know the amount of charge from which run machine. From it would be the function to the amount of the rotating. Yes. So I can say that the reporter shouldn't just use another device to measure the amount of charge on the plate. Yes.
And I agree with the reporter, and I think the reporter need to be more investigate in this part and show the just that or number in the presentation, and let me sure.
Yes.
I want to finish my question. To the same question to the opponent and the reviewer. The opponent is first what do you know about type A and type B uncertainty?
So I can say that the report has to do a lot of experiments and calculate the average and the standard the deviation. So that they can know the type A of the uncertainty. And for the type B of uncertainty, it's the minimum unit of the divide. So I asked the reporter about the minimum of their measurements. Yeah. So this is, and they got the type C uncertainty to calculate the.
Can I say some for review?
I think the type A is the error of the experiment and the type B is the error of the each setup. And this is my explanation of the type A.
I got a question. You mentioned about the size. Your ball is 2 centimeters, right? So when you did the calculation, you consider that as a point charge or whatever distribution of the charge on the ball?
I think because my ball is hollow, so I think the charges should be distributed on the surface beautifully.
So you took it as a point charge?
Yes.
All right. Okay, thank you. So here comes scoring time. Take your time. No rush. Take your time. All right, so ready? Okay, show your score for the reporter. Oh, start from me. 5, 4, 4, 5, and 6. Score for the owner. Start from me. 6, 5, 5, 7, and 7. Score for reviewer. Start for me. 8, 2, 5, 7, and 7. I think there's a single law, so I have to ask you to say a few words.
Well, because I think the reporter is not doing very good, but the reviewer did not actually point out. And when she tried to review the reporter and the opponent, most of those are empty. Because when, so for example, we ask if the ball is hollow or solid, will it affect? It's yes or no. But then nothing. Would it make the accuracy better, or would it reduce the uncertainty? Nothing. So it's just, it's empty. The question is empty because there's no consequence. So this is
All right.
yeah.
Okay, I understand.
One example.
Okay, all right. Okay, so we're gonna conclude this 5. So we'll take a 10 minutes break, right?